मॉर्निंग चिल्ड्रन। क्लास 12 फिजिक्स में कूलम्स लॉ इन वेक्टर फॉर्म is a very important concept and many of the children they are just confused about how to use the vector form of Coulomb's law in true nature, right? Like everybody you know about the Coulomb's law, F equals k q1 q2 upon r square, or inverse square law of Coulomb. But when you apply it for the vector form, like there is one positive q1 charge located here, and let us say there is one positive q2 charge located here, right? There are two positive charges q1 and q2, and the distance between them is, let us say, r. Now if you apply the Coulomb's law in vector form, now you see what is going to happen here. Because of the positive charge of q1, the positive charge of q2 will be repelled by a force, right? In same way, the positive charge of q2 will repel the charge q1 with a force, right? Now if the distance of q1 to q2 is r, in the vector form, suppose this distance I am writing as r. Now I can write this distance with r with unit cap in a particular direction. The r can be indicated in rightward direction, or the r can be indicated in leftward direction, right? This is what happens in vector form. When you apply Coulomb's law in vector form, q2 will be exerted with a force on charge 2, F2 I am writing, force on charge 2 due to 1 in the vector form, so I am writing this in the vector form, F21, F21 force. Read along with me. Force on 2 due to 1, force on 2 due to 1, right? And here what will be writing? This will be the force on 1 due to 2, force on 1 due to 2, right? So when you are going to write the force on 2 due to 1, say force on 2 due to 1, this is in the vector form. So force on 2 due to 1 will be k times of q1 magnitude, q2's magnitude, both are positive in nature, so you can write positive in nature, upon the magnitude square or square of the magnitude. So r vectors magnitude square, this will be your magnitude of the force, k positive q1 into positive q2 upon r magnitudes square. This is the magnitude. Now the directions for 2 to 1, will be r unit cap, with which direction will be getting for this is the direction is from 1 to 2. The direction is from 1 to 2. So you will be getting this is the direction from 1 to 2. So this is what we write. Force on 2 due to 1 is k positive q1 into positive q2 upon r magnitude squares with r unit cap, but r unit cap is having a direction from 1 to 2. This is the direction, right? 1 to 2. Similarly, if you are writing force on 1 due to 2, force on 1 due to 2. Look at here, what you are going to write, same again, K with positive Q1 with positive Q2 upon the same magnitude R's square with the direction. Which direction? The force on 1 due to 2 is acting in this direction. In this direction. So you will be getting this as R unit cap with which direction? 2 to 1. 2 to 1. So this is how you will be applying the Coulomb's law in vector form. Coulomb's law in vector form for the two positive charges. Force on 2 due to 1. Ready? Is your Coulomb's law with one unit vector. Direction is also assigned. Right? Now, many a times this you can write as K times of positive Q1 into positive Q2 upon R magnitudes cube with R1 to 2 vector. Because if I am multiplying one R on the numerator and on the denominator, this will be looking like this also. So many a times the children get confused of that is it a inverse cube law? No, not at all. It is not an inverse cube law. See here, one R is already there and this is R cube. So you will be getting R square. Inverse square law is only holding good and the directions will be maintained. Right? Same way, here also you can write this as K times of positive Q1, positive Q2 upon R magnitudes cube with R 2 to 1 vector. Right? So this is how you are going to represent the Coulomb's law in vector form for two positive charges. Let us take one of the charges negative and try to understand what is going to happen for this, right? Say one of the charge I am taking as negative, right? This charge suppose I take as negative charge, right? So this will be now change the scenario of the force of repulsion is now converted to force of attraction, right? Because of the Q1 and Q2 are opposite in charges, what you will be getting is the force on 1 due to 2 will be in this direction. Force on 1 due to 2 will be in this direction. And force on 2 due to 1 will be in this direction. They are attractive in nature. So both the charges will attract each other now. Right? So what will be writing here again, you look at force on 1 due to 2. Force on 1 due to 2. Same magnitude you can write as K, positive Q1, negative Q2 and r magnitude square with the direction. With the direction. Which direction the force is acting? Force is now acting from R. This is the direction. Force on 1 due to 2. Force on 1 due to 2 is acting in this direction, right? Q2 is pulling it. That means this is the force of attraction. So force on 1 due to 2 will be in the direction of force, direction of the force 1 to 2, right? Similarly, force on 2 due to 1, force on 2 due to 1 is also attractive in nature. So K, positive Q1, positive Q2 with R magnitude square with force on 2 due to 1 is acting in this direction. In this direction. What is it? 2 to 1. That means here also you can see force on 1 due to 2 and force on 2 due to 1 are opposite to each other. R unit cap with 1 to 2, R unit cap with 2 to 1. That means the direction of the forces are opposite to each other. That means they are attracting each other. They are attracting each other. In the first case also you will see the directions were opposite to each other. They were repelling each other. Right? And had it been a case of negative and negative also, then you can do the business of this. And as I wrote in the first case about how to write with a R1 to 2 vector and this as the cube also is holding good. So don't get confused of what and how to apply the Coulomb's law in vector form, right? Coulomb's law in vector form clearly tells about the directions also and the magnitude also. But whenever you apply, the same Coulomb's law is holding good and the forces will be equal and opposite in direction. The definition of Coulomb's law is not going to change, but you should be mathematically knowing clearly how this happens in vector form exactly. Okay, thank you. Good day.